Hey guys, Mrs. Allgood here. I am here to review with you concerning pH and negative and positive feedback. So this is going to be a short review today. This is for a Friday, so just keep up with the assignments that you've got due and when. I think tonight the properties of water assignment is due. Tomorrow night the biochem multiple choice is due. And then Monday night your enzyme FRQ is due. Okay, let's get going. So just keep in mind here that pH is a measure of the relative hydrogen ion concentration in a solution. So while I don't think you'll have to do any calculations with that, just keep in mind that if something has a pH of 5 on the pH scale, that means that its hydrogen ion concentration is 10 to the negative 5, or 0.00001, okay? So the closer that pH is to 0, the higher the hydrogen ion concentration. Because notice that when you get all the way down here to 14, look how small that hydrogen ion concentration is, okay? So keep in mind that 1 unit change on the pH scale is a change by a factor of 10, okay? And so this second bullet we'll deal with down here. But notice here, this is showing you that 10-fold difference for each unit difference on the pH scale. So if we were comparing a solution with a pH of 4 to a solution with a pH of 6, remember that each unit different on the pH scale is a 10-fold difference in hydrogen ion concentration. Okay? So if I wanted to know how much more acidic a solution of a pH of 4 is compared to a solution with a pH of 6, that would be 10 times 10, which would be 100. So there are 100 times more hydrogens in a solution with a pH of 4 compared to a solution with a pH of 6. As you get closer to the 14 end, obviously your concentration of H pluses goes way down, but your concentration of OH minuses goes up, okay? So I like this diagram because if we were to look at it, you know, right at neutral, right here, well, hold on. If we were to look at it right at a neutral pH of 7, okay, at 7 I have equal amounts, okay, equal amounts of H pluses and OH minuses. As I get closer to 14, obviously my amount of OH minuses increases. As I get closer to 0, my amount of H pluses increases. Okay, but at 7, the amount of those should be equal. All right, next, let's look at the parts of a feedback loop. Okay, this is definitely a contender anytime they tell you there's going to be a free response. In years past, I've seen this asked a lot. In multiple choice, there's always at least a couple examples, whether it's with hormones or whatever, that involve a feedback loop. So just be familiar with the different parts here. Obviously, the parts that I'm going to tell you about are things you could probably look up online. So not that they're going to ask you these parts directly, but they could have an example for you to apply your knowledge with. All right. So the first part of a feedback loop is going to be the stimulus. Okay, that's what's causing the change. It could be that you're too hot. It could be that you're too cold. Okay. Next, whatever is changing, that's got to be picked up. Sorry, that's too big. That's got to be picked up by a receptor. Okay, so that could be a temperature receptor in your skin. Okay, and then after that, then that receptor is going to send an afferent message to the control center. Okay, the control center is going to be something like your brain or your spinal cord. Okay, And then your control center is going to send an efferent message to an effector. Effectors are always going to be your muscles or your glands. Remember, we said the control center is going to be your brain or your spinal cord. And then finally, you've got your response, and that can lead to your negative or positive feedback. So let's look at the difference between negative feedback and positive feedback. All right, your negative feedback means that it's going to lessen the intensity of the original stimulus, or sometimes we say that you are trying to negate the original stimulus. You're trying to lessen it. Okay? Charlie, stop. With positive feedback, the response or the outcome is trying to strengthen or amplify the intensity of the original stimulus. Okay, so this is an example like with blood clotting or childbirth. Okay, so this is how a typical feedback loop would look. You've got your stimulus, and whatever change that stimulus is causing, that's going to get picked up by receptors. Then those receptors can send that change to the control center. Effectors are something in your body, like muscles or glands, that can actually do something about your problem, and then they're going to initiate some kind of response. Okay? So let's think about a specific example here. So if we had a stimulus, maybe the stimulus would be like, this would be like cold temps on your skin. Well, how do I know that I'm cold? Well, because you're going to have temperature receptors in your skin that pick up that sensation of being cold, and they're going to typically send a message to your brain, more specifically probably your hypothalamus, because that's the part of your brain that deals with temperature. And then let's think about what happens in your body when you get cold. Okay, well, you shiver. Okay, well, that's going to be a response. The reason that you shiver is because we stimulate your skeletal muscles. Okay, your skeletal muscles contract. Okay, and that's what's going to cause the shivering. All right, well, what else happens when we get cold? Well, we get goosebumps. All right, well, why do we get goosebumps? Well, because when we get cold, our erector pili muscles in skin contract. Okay, so when that's one of our effectors. Remember, we said effectors had to be muscles or glands. So these are both muscle examples here. Okay. Sorry, that's my dog's collar jingling. What else? We have smooth muscle in the walls of your blood vessels. Okay, and if we're cold, that's going to cause vasoconstriction, which basically means it's going to make the diameter of our blood vessels smaller to limit heat loss. Okay, so all of these things, shivering, goosebumps, vasoconstriction, this is going to cause negative feedback because it's going to this is all trying to warm you up, which should be negating the original stimulus of cold temps on your skin. Okay, positive feedback loop, the classic example that we used for this was childbirth. So again, the baby's head kind of gets pushed further into the birth canal. That's going to it's going to activate stretch receptors in that area, which is going to send signals up to the brain. The brain stimulates the pituitary gland to release oxytocin. Oxytocin gets carried into your uterus, which is going to stimulate stronger uterine contractions, which is going to push the baby further into your birth canal. Again, when that baby gets pushed further into the birth canal, that's going to cause there to be, to activate more stretch receptors in that area. And so this is going to keep going around and getting stronger and stronger and stronger every time until the baby is born. Okay, that's positive feedback where the stimulus gets stronger and stronger every time. All right, that's it for today. I'll talk to you again Monday.